Hello, White Hill students! This is Mr. Long, and I am going to be walking you through your notes today. So, please, as always, go ahead and bust out those math notebooks of yours and turn to a brand new page. We're going to be writing everything I write, so go ahead and title the top of your page, Shapes in Distributions. And again, like I said, it's an I write, you write, so go ahead and write down what I have on the screen. Teachers, if I am going too fast, go ahead and pause the video. I'm not going to be mad. I'm not even going to know. I'm just a recording right now. So go ahead and pause the video right now to make sure all your students have a chance to write it down. Okay, pause it now. Okay, I hope you all had a chance to write down your stuff. If you were wondering, what is that little guy in the top left corner? That is Mango, and he is going to guide us through our lesson today. So as mathematicians, it's very often that you're going to be looking at data, right? Math is used in the real world all the time, and we use it to kind of look at data and trends to kind of predict what will happen later on, right? So Mango, this hamster, in case you guys don't know, hamsters are nocturnal and they sleep during the day and they wake up during the nighttime. They run around like crazy and they do the little squeaky squeaks and they're super cute, but they do that during nighttime. And Mango is an extra athletic hamster, so he runs more than the average hamster. So I was wondering, how many hours does Mango run in a night? So I asked my brother, paid him $1 or $2, and he sat up every night and observed Mango as he ran on the wheel, and he counted how many hours he ran. Okay, so here's the data that he showed. So this is hours of running. And I paid my brother to do this for 2 weeks. Yep, he didn't sleep for 2 weeks. He just watched Mango run. So here is the data that he collected. So we got the data as 1 hour. So during this day, Mango only ran 1 hour, right? Maybe he was a little lazy. He got 2 hours, 2 hours, which means that there's 2 days where he ran 2 hours, right? 3, 3, 3, and 3. This means that there are 4 days in which Mango ran 3 hours that night, right? 4, 4, 4, 5, and 8. Okay, so over a 2-week span of time, right, this is the data that we have collected for Mango. Now, I'm going to go ahead and draw a number line over here, and we will be plotting these points in a dot plot. Now, I know some of you probably have no idea what a dot plot is. We learned about dot plots way back in like chapter 1 or 2. I don't know if you remember, probably not. But if you do, good on yourself, good on you. Give yourself a little pat on the back. So we're gonna go ahead and put this into a dot plot. So I'm gonna go ahead and number my stuff. So we got 1, 2, 3, 4, 5, 6, 7, and 8. So you guys should be numbering this with me too. So make sure you write down all the things that I am writing down. We got 1, 2, 3, 4, 5, 6, 7, 8 on this number line. All right, let's go ahead and start plotting our data. So how many times does the value 1 show up? Well, 1 shows up 1 time. So I'm going to put 1 dot on this 1. Okay? How many times does this 2 show up? Right, it shows up 2 times. Here we go. We'll put 2 dots on that 2. And now, just like Dora the Explorer would ask, how many times does 3 show up? Good! Cross those out, and we're going to put our 4 dots on 3. Okay, because it showed up 4 times, right? And then we're going to do that for the 4. We see that 4 shows up 3 times. 1, 2, 3. You see that 5 shows up 1 time. Okay? And we see that 8 shows up 1 time. All right, let's pause here really quick. So teachers, go ahead and let your students talk for a bit, but about this. So look at this graph really quick. What do we see? What do we notice about this graph? Okay, just what do you notice? Is there anything weird? Is there something not weird? So go ahead and talk about it. Teachers, pause the video, let them talk for like 30 seconds, and we'll all come back. Go ahead and do so now. Okay, so I don't know if you guys noticed. Maybe some of you noticed that the hamster's cute. Maybe some of you noticed that there's a lot of dots on the left side, maybe not so many on the right. And maybe some of you might have really noticed this weird little data point right here. See that 8? Why is there a dot all the way over where that 8 is when most of the dots are on the 3, right? If we were to find the average, we would like to think that the average would probably be around 3 or 4, right? So 8 is called an outlier. This is a number that is far greater or far smaller than the total everything else, right? So go ahead and write this down under the definition of outlier. So an outlier is a data point that is much larger or smaller. So outliers are really interesting because we like to look at them and see how it affects our data. Sometimes it actually does mess up our data quite a bit. And sometimes it shows some weird anomalies, right? Or maybe even mistakes that might have occurred. So let's look at our hamster here. Can somebody give me a reason for why there was one night when Mango ran 8 hours? Teachers, pause the video, let the students talk again. Go! All right, what crazy ideas did we come up with? So maybe, I was thinking, maybe we fed Mango too much food that day and he had a lot of energy. So whatever that day was, he ran way more than he normally did. Maybe he just had a lot of energy that day and just wanted to run extra. Or maybe my brother, who I paid minimum wage, did not count correctly. Maybe he fell asleep and he's like, they'll never notice if I just make up a number, and he just said 8, right? These are all different valid reasons why this outlier might have existed. But it's really important for us to look at these outliers because it does skew our data. And what does that mean? Well, that's what we're talking about next. So a data that is skewed is pushed to either the left side or the right side. There are 3 types of skews. We have a symmetrical skew. So when the center of the graph, right, is exactly the center of this like mountain almost, so this is called symmetrical. We have when the data is, the tail of the data is on the right side. So say the right side has like this thing and it kind of goes like this. This is called skewed to the right. So that means the tail, the long part, is on the right, just like our data here, right? And then we also have skewed to the left, which means that if this was the center, the tail would be over here, right? So that's skewed to the left. So we have symmetrical, skewed to the left, and skewed to the right. So in our example with Mango, we see that our data over here is skewed, right? It's skewed to the right because most of the data points are on the left, and all the weird numbers, the number that probably doesn't belong, is on the right. So this whole data point is skewed to the left. Okay? And very lastly, we have our gap. So a gap is a space in the data. So here we have 2 gaps. We have one gap, and that's where the 6 and the 7 are, right? 2 numbers. So a gap is also very useful for us to think about how accurate that 8 data would be. So it's kind of strange that most of the time he ran 3 to 4 hours a night, and then all of a sudden, right, he did 1 hours he did 5 hours in that one night, and then he didn't do any 6-hour nights or any 7-hour nights, and somehow he did an 8-hour night. Pretty fishy to me. So a gap in data is sometimes very useful for us to find mistakes, and sometimes it's just useful to analyze. There might be some other reasons there, right? So those are the 3 big words we are learning today: outlier, skew, and gap. So let's do some practice right now. All right, coming on over to this next page. And teachers, again, pause the video, right, if I am going too fast. We're going to go ahead and talk about outliers, gaps, and skews on this next example. So pause the video and let your students copy down what I have. Do so now. All right, are we ready? So we're going to think about first the skew, or we can do it in any order. Let's do skew first, or outlier first. Yeah, let's do outlier first. So let's think about the outlier. Are there any outliers in this example? Well, if you look at this data, we can see that there is an outlier over here at the 2. Notice how most of the data is on the right side and there's one really far away and there's a gap in the middle. So the outlier in this case would be 2, the number 2. Now, is this data skewed to the left or the right? Teachers, maybe pause the video right here and check your students. Maybe they can point to a certain direction. I can't tell. I can't see you. I'm only recording. So if you guys said this data is skewed to the left, you would be correct. Because if you draw a center line through our data right here, we can see that if we drew a little tail in a mountain, right? Most of the data is on the right side, which means the data is skewed to the left, okay? So the skew, in this case, would be left. And lastly, we're going to go ahead and talk about our gaps. Do we have any gaps here? And yes, it does look like we have a gap here. Our gap in this example would be from 3 to 4. There's a gap. Doesn't seem like there's anything there, right? So that is our gap. All right, so you're going to be having some practice with this in your homework. And this is a good time for us to kind of talk about it and do some together. Now, here's another data display that we can look at. This is a histogram, right? Are these coming back to you? So in this histogram, we're going to take a look at our data points. So I know you can't get an exact idea of how much these numbers are, but sometimes it's nice for us to just kind of look at the shape and think about the shape. So in this example over here, go ahead and see if you can figure out the outlier, the skew, and the gap. Okay, are you ready for the answer? So the outlier in this example, outlier, well, is there an outlier? I would say, honestly, that there's no outlier. They're NA, because there's no number that really falls far away from the data point, right? So I would say, no, there's not really an outlier here. Is there a skew here? Some of you might say that this data is skewed to the right, because if we drew a line down the center here, right, it is slightly to the left side, so it could be skewed to the right a little bit. Some of you might say it's symmetrical. I would say for this one, maybe it is skewed to the right a little bit, but I can see how some people would think symmetrical too. So I would say just for now, this is skewed to the right. And lastly, is there a gap? And again, just like the outlier, there is no gap because, well, look at it. It's all kind of contained together, right? So therefore, this is how we do it. All right, guys? So again, you'll have some practice. If you have any questions, ask your teacher. I can't hear you because I am on a video, but good luck and you guys can do it. All right, bye-bye.